Okay, so first this lab will for 2 or 3 weeks according to your process. Okay. So experiment 4 logical gates. So for this lab, we will use 2 gates, Ladder and Law. Okay, so use these 2 gates. Then, so for the chips, we will use 7400 Cloud 2 input NAND gates. So this means this chip has 4 NAND gates inside. 7402 also Cloud 2 input NOR gates. Then we also need 2 1 kilo ohm resistor. Go to the last one first. Okay, so this is the 7400. Okay, so this is the pin out. 14 pins, the same. So 1 and 7 for pin 7 for ground, connect to ground. Then 14 VCC connect to the power. Then again, so the pin number order in the counterclockwise direction. Counterclockwise. Okay. So 1, 2, 3 like this. So 4 NAND gates inside. For this one, so 1 and 2 are inputs. 3 is the output. This one, so 4 and 5 are inputs. 6 is output. This is 9 and 10 are inputs. Then 8 is output. This is the 12 and 13 inputs. 11 is output. So this is the NAND gate. NAND gate, we said before, is load and gate. So for this one, you can think about dual AND function first, then dual negation, flip the result. This is the LOR gate. LOR gate is different. So 7402. You can see for this one, 2 and 3 are inputs. 1 is output. So totally different. Okay. This one, so 5 and 6 are inputs. 4 is output. 8 and 9 are inputs. 10 is output. 11, 12 are inputs. 13 is output. Then 7 ground, 14 VCC, this is the same. So this is the chip we will use for today. Okay. Okay. So for logical gates and for the Boolean logical, so we know only has 2 numbers or 2 states, 1 or 0, right? 1 or 0, or high or low, true or false. Only these 2. Okay. So for the Boolean logical 1 and 0 according to the positive logical or negative logical. We talk about this in the first class. Positive logical, so 1 is high. So 1 is high, 0 is low. This is for positive logic. And for high value, we did this, I think, in the step 2. High value usually is from 2 to 5 volt. This is volts for voltage. Then 0, the low, so it's from 0 volts to the 0.8 volts. So this means for TTL logic. So if voltage is positive 2.4 volts, then this means logic is 1 or is high. Okay. Then if voltage is 0.4 volt, then it's 0 or low. Okay. Then for the negative logic, then AVC is opposite. Okay. Then for this one, so for negative logic, then positive voltage is 0. Then less high positive This means high positive logic is 0. Less positive voltage is 1. So this means 1 is for low, 0 is for high. Okay. Then if for voltage, then is 0.4 volt, positive 0.4 volt is 1. That means high. Then 2.4 volt, that's the 0, so it's low. Okay. So this is negative logic. Negative logic we seldom use. Most time, so we use just positive logic. Then for this one, this is the negative OR gate. We also learned this in class. Negative OR gate. So just like this. So input 0, 0, then flip at the input side. So this means then inside this OR gate, so it's 1, right? Then 1 and 1. For all gate, so that's all function. So we know it's the D. 1 plus 1, then result is 1. Then flip, negation at output side, flip, so output is 0. Then 0, 1, similarly, so after negation, so it's 1 and 0. 1 plus 0 is 1, flip, so output is still 0. Then 1, 0, this is the same because inputs don't have order, right? So then it's 0, 1, output 1, flip, so it's 0, flip. So this is then 1, 1. So here shows the AND gate here. So actually, we said this before. Negative OR gate is the same function. Its function is the same as the AND gate. So 1, 1, then 0, 0, right? 0 plus 0 is 0, flip, then we can get the output is 1. Then the same here. So negative OR gates its function is the same as the AND gate. Okay. Okay. So this is the truth table we just did. So low, low, output is low, low, high, output is low, high, low, output is low, high, high, output is high. So this is exactly the AND gate or the negative OR gates. Then, so for today, so we will build truth table from our circuits, okay, for LANA gate and NOR gate. Then before do this, so we need to go to here. So last time we used the decoder, the BCD code decoder, right? So we used this before. So if for the pin with the circle and with the over bar here, so this means this pin will get true when input is low. When input is low. So input is low after negation, so it's high inside, right? So this one, so this the variable is true, so true. Then for this one, ready and test. So without the negation, right? So this means we will get a high value, then they are true. So high voltage, when input a high voltage, then they will true. A here, this one, so this is the same, so it's low. Low, then A is true. Low, okay. R slash W8. So this means for this pin, it's actually, so it has 2 and 4 for 2 different status. If you get the high voltage, then R is true. R here for the read. So this means the chip is in read mode. If the input is low, then W will be true. W that's for written, for writing. So this means input is low, then the chip could be written something inside. So this is R/W bar. Okay, so then for here, so this is the gates we learned before. There are 2 columns. Left columns distinctive shape symbols. Usually we call this is classical the symbols. Okay. The right corner, this is rectangular outline symbols. This is the modern symbols or the ISO standard symbols. NC IEEE, so this is the standard organization. Okay. So first, the LOT gate. So LOT gate has the 2 types. This one we know negation at the output side. This is the negation at the input side. Okay, this is the LOT gate. Then for the modern simple, use the rectangle, 1 inside, then small triangle, that's for the negation. Output side, input side. AND gate, so classical, this is the modern one, rectangular, so just the AND symbol inside the rectangle. OR gate, then for the OR gate, rectangular, so it's greater than or equal to 1 inside the rectangle or square. Then NAND gate. NAND gate, so negation at the output side of the AND gate. Then now has the small triangle at the output side. Compare these 2 difference, just the small triangle, right? So AND gate, NAND gate. The NOR gates, also small circle at the output side, then small the triangle at the output side. XOR gate, so XOR gate, and then for this one, so equal to 1. XNOR gate. XNOR gate we said before, so this is the complement of the XOR gates. Then small triangle at the outside could be equal or equal to 1 inside the square. So classical symbols and the rectangular symbols. Just for me, in my opinion, I prefer classical because in my opinion, classical is more straightforward than the modern symbols. Okay. Okay, then for this one, today, so we will build truth table. Oh, this is still the example for this case. Then this one, the LOT gate. LOT gate very simple. Input 0, output is 1. Input 1, output is 0, right? AND gate, we talked about before. So 0, 0, output 0, 0, 1, output 0, 1, 0, output 0. 1, 1, output is 1. Then OR gate, 0, 0, output 0, 0, 1, output 1, 1, 0, output 1, 1, 1, output still is 1. Just remember, AND gate is the multiplication, OR gate is the addition. Then XOR gate. So 0, 0, output 0, 0, 1, output is 1, 1, 0, output is 1, 1, 1, output is 0. So for XOR gate, I said before, so this means inputs are the same, output is 0. So 0, 0, 0, 1, 1, output is 0. If inputs are different, 0, 1, 1, 0, output is 1. XNOR gate. XNOR gate is the complement of the XOR gate, so negation at the output side. So output now is flipping, right? So 0, 0, output 1, 0, 1, output 0, 1, 0, output 0, 1, 1, output is 1. So inputs are the same, 0, 0, 1, 1, output is 1. Inputs are different, 0, 1, 1, 0, output 0. So for today, so we need to build the circuit from this one, then fill the truth table. So fill the truth table. So this is the NAND gate. This is the NOR gates. So 2 inputs, 1 output. Then the last one, so we need to connect this one. So actually, this we will get the NOR gate, okay? Similarly, this one, the NOR gate, just combine 2 inputs. Then this is 2 series, okay? This one a little bit complicated, so this is the 3, 1, 3 NOR gates. Then this is the 3 NAND gates, 3, so this is use the modern simple. Then this is the 2, the NOR gates. This is a NOR gate. So we need to build circuit according to the circuit diagram, then fill the truth table. So this is totally, so we have how many? So 1, 2, 3, 4, 8. So 8. So this is the 8 circuits. So maybe today you could finish 4 circuits or more. Okay, this is up to you. Then next week we need to finish at least finish the remaining the 4 gates. And also we still have one more thing to do. This one. This is the complicated one. A little bit complicated, not exactly. So maybe you could finish this the circuit in 2 weeks. If we couldn't finish this, so we will leave this the circuit in the 3rd week. Okay. So also depends on our the process. Okay. So for this one, actually use the 2 gates. So you can see 2 chips actually. 7400 NAND gates, 7402. So this is the NOR gates, right? Okay, so for this one, when you build this circuit, so now we don't have the photo to, like as a reference. We need to build everything by ourselves. Okay. Just talk about this first. So for build circuit, the better before you build this circuit, the better write down the pin number on this circuit diagram. Just for example, oh, sorry, this is not right. 7402, this is the NOR gates. NOR gates is different. So for the 7402, if you use the first NOR gates, 2 and 3 are inputs. 1 is the output. So go back here. Okay, I have circuit here. So this place, okay, this is the same one. So this means we need to write 2 and 3 are inputs. So connect to 2 switches. Then output, so is pin 1. Then for 0, 2, this pin 1, so now we need to connect to 1 and 2. So this one, the first NAND gate in the 0, 0. So 1 and 2 are inputs. Then 3 is output, so like this. So this means for when you do connection, pin 1 in the 7402 need to connect to pin 1 and 2 in 7400 like this. Then for this one, so maybe you can keep going. So 4, 5, then 6 is your final output like this. Then for this one, so this is we could use this one. So 8 and 9, then 10. So this is no, sorry, wrong one. So should be careful. So actually 8 is output for this gate. So this then we need 9, 10, then 8. So this is the output. So you can organize like this, then do connection with these pin numbers. Then for this circuit, so you can see when the switch is open, then this point connect to the 5 volts, right? So this means now input is high. If switch is closed, then this point connect to the ground. So this input now is 0 or low. So this is this one. Okay, so now go to the beginning. So first one, we need to build just the NAND gates, then build the truth table for one NAND gate. Then I draw the circuit diagram here. So this is the one, the NAND gate. So has the 2 inputs, right? 2 inputs. So inputs could be 1 or 0. Then I connect to the switch, then switch connect to the power, 2 resistors connect to the ground. So for this one, if the switch is open, then this point connect to the ground. So now input is 0, right? If the switch is closed, then this point connect to the 5 volt. So now input is 1. So we will use this switch, change the inputs, okay. Then for the output, so output now connect to 1 kilo resistor, then to LED, then to ground. So this means if the output is 1, then 1, so we know it's around 5 volt. So 5 volt, so the current can flow through the resistor, through the LED, then LED, so will be on. So this means if LED is on, the output is 1, the high. If the output is 0, 0, so its voltage is around 0 volt. 0, ground is also 0, right? 0 volt. So this means no voltage across the LED. So LED is off. So off, so means output is 0. So LED on, output is 1. LED off, output is 0. So this is the circuit diagram. Then this figure so shows the how to build with the chip. So 7400, 14 connect to the power, 7, pin 7 connect to the ground. Then pin 1, pin 2 are inputs, right? So we connect to the switch, then resistor, then ground, and the switch also connect to the power. Then pin 3 is the output. So goes to resistor, goes to LED, then go to ground. So again, if output pin 3 is 1 high value, then LED will be on. If the output is 0, then LED will be off. So this is the circuit. So for the circuit, So we will build the circuit according to the circuit diagram or according to this figure. Okay, so let's start this in the Tinkercad. Okay, so first one, let me change the name. So this is the NAND gate. Oops. Okay, something wrong. We have one more. This one. Unpair shape. Yeah, right. Why? Okay, think this. Change name first. Okay. Okay, so whiteboard. Me go to all. Oh, no, not. Oh, I have one there. Okay. Okay, so for this one, so this is let me make it smaller. So whiteboard. Then the last one, so we need the power, get the power first. So this is the DC voltage. Oh, no, no, no. This is, this one didn't change the name. Let me go back first. Okay, this one. Okay, smaller. Get power. So DC voltage. So this is DC voltage. So 5 volt. Okay, so we can connect to the power line in the circuit. Let me do this way. Okay, so this is the red. Then positive to positive. Then this is the negative. So negative, usually we also think about this is ground. Then negative to negative. Okay, so now this is the power. We get the power. So last, we need to get a switch, right? Two switches go up. I remember it's on the, yeah. So here we just need two, but we only have 4 or 6. So just use this 4. Just remember, we just need 2. Okay. This one cannot see clearly. So this is the pin. Maybe let me check whether I can connect it to here. Okay. Yes, so I can put it in this way. So then I would put the other behind. So then 2 resistors. So 1 kilo ohm resistors I can put in the 1 and maybe 1 and 3. Okay, this is 1 kilo, 1 kilo, you're correct. Okay, then go to ground, so connect to the ground. So we can also double check here, use a multimeter, because I'm not sure whether it's connected or not. So this is ground. Then connect to this one. Let me check open or close this switch. This voltage is 5 or not. So, okay, so this is open, so 0, close, 5. Okay, so it's correct. Okay, so we can keep going. Okay, so now we built this one. Then the last one, so we need the chip. So 7400, this one. Chip can only in along the gap. Okay. So for the chip, just remember the large or small circle. This is get the direction. So this is the pin 1, then 2, 3, like this. So this is 7, should go to ground. Then 14 is this, so connect to the power, positive 1. So connect, change this to right. Okay, so when you get chip, so first connect the power pin and the ground pin. Okay. Then the last one, so pin 1, pin 2, so connect to the resistors. So pin 1, let me change the color to green. This is for the connection. So now pin 1, just go here. Okay. Pin 2, so let me drop this place. So this is the switch 1, switch 3. So goes to pin 1 and pin 2. Then pin 3 is output. So need a register, LED, then ground, right? So we need a register first. Okay, so maybe more. Okay, so this is one. This need to connect to the pin 3. So we can just connect here. So this is pin 3, output 1 goes to register. Then register need to connect to LED. So we need the LED. Again, so LED has the direction. So curve V1, this one is the positive anode. Then this is the straight one, this is the negative. So this is the cathode. Okay. For this here, if you go here, you need a positive connect to the positive lead of the LED. So this means we need a flip mirror this one. Okay. So positive, the negative, then from here we go to ground. Okay. So then we got this one. So now we can go to the table. This is this table. So we can run the simulation now. So 5 volt, right? So LED is off. Then input here, because I already closed this one. Let's open everything. So open, so this means the input, these two, sorry, this is not right. Sorry, I did wrong. We cannot go here. Go to this place. Sorry. If connect to here, this is always 0. Okay. For this place. Okay, so let me double check. So this is 0, 0. Output is 1. Why this is not on? simulation is different. Let me check again. So this is now open. So voltage here should be 0, right? So 0, 0, and function is 0, 0, flip. So should be 1. Why LED is not on? Okay, let me check the voltage first. Okay. Then negative, so go to ground. Positive, so let me go to output. Okay. Then run simulation again. Okay, output is 5. So 5, so this means our just LED is not on. Let me double check connection. Oh, sorry. This is connected to the positive power line. So should go to the negative. Okay. I also made a mistake. Sorry. Run again. Okay, so LED is up. So you can see the voltage now is 4.87. Okay, so just like this. So now we could write down the result here. So now at the beginning, the switch are open, 1 and 3 are open. So input 0, 0, output is 1, right? So you can write down the results here. So 1 measured output voltage, so just this number. So write down here, 4.87 volt, right? Then the last one, 0, 1. So this means we need to close switch 3. So this is close, output still 1, right? So this is 1. So 0, 1, so we know then 0 times 1 is 0, flip, so it's 1, right? So this is correct. So 4.87 volt. 1, 0 should be the same. So open switch 2, close switch 1. So 1, 0, so LED is on, high voltage. Just keep right this. So 1, 4.87 volt. Okay. Then the last one, 1, 1. So just close switch 3. Okay, so 1 and 3. So now LED is off. We get the 0 volt. So the output is 0 because LED is off and also low voltage here. So this is 0. So for you, just do like this. Okay. So this is the first part. And also you the better just finish the one chip first. So you don't need to change the chip because we said before 7400 and 7402, their pin out are totally different. Okay. So you the bet in the real part, you also need to switch the chip. For here, doing this is not difficult, but you also the better just finish one chip first. So this means finish this table, then keep going to 4-4. This is the NAND gates, just combine these two inputs. This means you need to connect pin 1 and pin 2, right? Then do so just has the two status, 0 or 1. Then get the output. Then goes to table 4-6. This use the NAND gates in this chip. The same, you the better before you build this one, the better write down pin number in this circuit diagram. For example, we know 1, 2 are inputs, pin 3 is output for the first gate. Then second gate, so it's 4 and 5 are inputs. 6 is output, right? Then this means the 6, so you need to connect to the resistor, the LED, then we can show the result, right? So this is this one. Then you have one more, the NAND gates. Yeah, so it's this one. So you need to use 3, the NAND gates. Again, the better writes down pin numbers first in the circuit diagram graph, then build the circuit. And when you finish this, the NAND gates, if you have time, so you can go to the NOR gates. Then one NOR gates combine the inputs, one NOR gate, then 3 NOR gates, okay, and then 2 NOR gates. Also, so again, so finish these 8 gates, 8 circuits, then go to the last one, okay. Hopefully, we could finish this in 2 weeks. If no, so we can go to the 3rd week, okay, 3rd week. Okay, so for this one, I just showed the first part, and then let me just do one thing more. So this is, let me erase this first. Okay, so for this one, so we don't need to change the circuit, the connection here. We just need to connect this pin 1 and pin 2, right? So pin 1, pin 2, so we can just draw a short line. Oh, stop simulation. Okay, change this to green. Okay, so now pin 1, pin 2 are connected, right? So we can just use one switch, change the status. So anyone?
Excuse me, sir.
Yes?
I'm not sure if it's only me, but I don't see this on Tinkercad. I can't see the class.
You cannot see.
Yeah, on Tinkercad, I only see the 121 one,
You can
but I
use
don't.
the class code. Do you remember? So just go to announcement, use the
Oh, okay.
class code, then join the
All right.
class. Yeah.
Okay.
Yeah. So in this way, I already connect the pin 1 and pin 2. Then, so this means I can just use any one, switch 1 or switch 2, change the inputs. So run simulation. Okay, so let's open this first. So now this is the high because this is closed. Pin 1 is closed, right? So LED is off. So no value. So this means input 1, output is 0. Then if open this one, input is output is LED is on, so output is 1. So from truth table, so it's clear this is the NOT gate. Output just flips the input. Okay. So first 2 are very simple. Then this one a little bit complicated. Then this one you should be careful because you will use the 3 gates. Okay. Okay, so is this one? Let me stop record first.